All right, let's do another example where we interconvert between different units of concentration. In this example, I have a 0.944 molar solution of glucose, which has a formula C6H12O6 in water. All right, so sugar water. This has a density of 1.06 grams per milliliter at 20 degrees Celsius. You need to calculate the mole fraction, mass percent, and molality of this solution. All right, so in this problem, you are given the molarity, and you're asked to convert that molarity to mole fraction, mass percent, and molality of the solution. One thing you should stop and think about is what is the solute and what is the solvent? I recommend doing this with any concentration problem because it'll help you with the definitions. The solute here, of course, is the glucose, C6H12O6, and the solvent is the water. So this will come in handy later as we try to define what all of these things are. Now, what I like to do when I'm given a problem like this and I have to interconvert between units of concentration is I start with the concentration that I'm given. I have 0.944 moles of glucose per liter of solution. That's what molarity means. Moles of solute per liter of solution. Now, a really good trick to figuring out these kinds of problems is to use the denominator to make an assumption. So use the denominator of the concentration unit that you're given to guide an assumption. Now, the denominator is liters of solution. So what that means is that I'm going to assume I have 1 liter of solution. Okay, this isn't the way that you have to solve the problem, but I find this a very useful way to start interconverting from one unit to another. If I assume that I have 1 liter of solution, then because I have 0.944 moles of glucose, moles of C6H12O6 per liter of solution, that means that I have 0.944 moles of glucose, C6H12O6. Now, what I want to do is convert that to mass percent, mole fraction, and molality. I'm just going to arbitrarily start with mass percent. You could start with whatever one you want, but if I have a certain number of moles, then I can use the molecular weight of glucose to convert moles to grams, and that's going to be useful in going towards mass percent. So if I have 0.944 moles of C6H12O6, this is assuming I have 1 liter of solution, I can use the molecular weight of glucose, which is 180 grams per mole, to convert that to 170 grams of glucose. Once again, this is how many grams of glucose I have in 1 liter of the solution. Now, how many grams of solution do I have? Once again, I can get that from the 1 liter assumption that I have, right? Remember, mass percent is going to be the mass of the solute, which is the mass of C6H12O6, over the total mass of the solution. The mass of the solute over the mass of the solution. I already have the numerator, and from the 1 liter of solution, I can get the denominator because the problem gave me the density, okay? The solution has a density of 1.06 grams per milliliter at 20 degrees Celsius. So if I'm assuming I have 1 liter of solution, that 1 liter of solution can be multiplied by the density, 1.06 grams per mil, and then I want to interconvert milliliters and liters, and that leaves me with grams. 1,060 grams of solution in 1 liter. So now I have what I need to get the mass percent. The mass percent is going to be equal to the 170 grams of solute, C6H12O6, divided by the total mass of the solution, which is 1060 grams of solution. That's going to give me a mass percent of 0.16. If I multiply by 100, that's 16%. Okay, so this solution is 16% by mass glucose. Okay, so 16% of it is glucose. The remaining 84% of it would be water by mass. All right, now I can pick any of the other ones to interconvert next. Let's pick molality. I'm going to remind you what molality is. Molality is the moles of solute, in this case, that's the moles of C6H12O6, over kilograms of solvent. So in the denominator, I need just the kilograms of water. So I can use the information from the previous problem to figure out that denominator, right? Because I know that I had 1,060 grams of solution. And if I subtract from that the number of grams, what was it, 170? 170 grams of glucose, that gives me the number of grams of solvent, the number of grams of water. So I'm going to have 890 grams of water. And converting that to kilograms, that is going to be divided by 1,000, 0.890 kilograms of H2O. So again, I am still operating under the assumption I made at the outset, the assumption that I have 1 liter of solution. So in that 1 liter of solution, I still have 0.944 moles. So to calculate the molality, little m is molality, I have 0.944 moles of glucose for every 0.890 kilograms of water. And that gives me a molality of 1.06 molal, little m. I can express that as little m or moles per kilogram or the adjective molal. So this is, again, the molality of C6H12O6 in this aqueous solution. All right, the final task is to convert the concentration to mole fraction. The mole fraction of glucose is going to be equal to the number of moles of glucose, so the number of moles of C6H12O6, plus the number of moles of all the components of the solution. That's going to be the number of moles of the C6H12O6 plus the number of moles of water. Once again, I want to use the assumption that I have 1 liter of solution because I already know that in 1 liter I have 0.944 moles of glucose. So I just need to figure out the number of moles of water to add to it in the denominator. So 0.944 moles of glucose plus however many moles of water. Let's figure out how many moles of water I have. Once again, I can go back to my previous calculations, and it's going to be very useful to look at this 890 grams of water because I can take that value and then use the molecular weight of water to convert it to moles. So 890 grams of water are in 1 liter of that solution. And I'm going to multiply that by the reciprocal of the molecular weight of water, about 18 grams per mole. So 890 divided by 18 is 49.444 moles of H2O. So I can put that in my denominator up here, 49.444. I kept 3 digits so I can add it to the same number of decimal places as I have the number of moles of glucose in. Okay, so that's the number of moles of water. And this gives me a mole fraction of, okay, here, let me draw a line here, a mole fraction of 0.0187. Now, the mole fraction is unitless. This is telling me the molar ratio of the number of moles of glucose to the total number of moles of everything in the solution. So a mole fraction should always be between 0 and 1, and it has no units. So 0.0187 is going to be the mole fraction of glucose in this particular solution.